Good afternoon to you all. My name is Masala. So we are going to continue with our differential calculus, and we are going to continue with chain rule. We call it chain rule or function of a function. Some textbooks can call it function of a function, and some will call it chain rule. Now, when do we use chain rule? We use chain rule when we are dealing with power or roots. That is, for instance, when we have y equals 2x raised to the power of 3 plus 4 raised to the power 3. Now, we use chain rule or function of a function when we have a power or we have a root. Now, how do we do this? Now, if you are told to find the y, the x, that is, you are told to find the differentiation of y with respect to x. Now, how do we do this? The chain rule, the formula we use for chain rule is, we say let u equals 2x raised to the power 3 plus 4. Now, let's say u equals, so if u equals 2x raised to the power 3 plus 4, then automatically it means y equals u raised to the power of 3. Okay? Now, with this now, we have u equals this, then y equals u raised to the power 3. Now, for the formula, we now say dy dx equals dy du multiplied by du dx. So this is what we call chain rule. That is, if dy dx now be what? Dy du multiplied by du dx. So we are going to find the differentiation of u with respect to x and y with respect to u. Now, du dx here, from here, we have du dx will now be equals to, this will be 6x raised to the power 2 plus a constant to give us 0. So dy du will be equals to 3 u raised to the power of 2. Now, after differentiating this, we now fixing back what our u is. That is, we now have 3 in open bracket 2x raised to the power 3 plus 4, then square. So we have our du dx and we have our dy du. Now we just fixing back this into the formula. So we are going to have dy dx equals dy du. Our dy du here is what? 3 open bracket 2x raised to the power 3 plus 4 all square multiplied by du dx. And our du dx here is 6x squared. Now, having done this, then we can, the rest is mathematics. We say 3 multiplied by this, but we cannot multiply 3 with this because of the square. So the 3 can multiply this. So we have dy dx will be equal to 6x squared multiplied by 3, and that is 18x squared, open bracket 2x raised to the power 3 plus 4 all raised to the power 2. So this is the way we differentiate when we have power or roots. Or maybe I take another example. Let's assume you have y equals 2, or let me say 4x raised to the power minus 3 plus 4 plus 2x raised to the power 3, then, okay, square root. Now, when you have something like this, the square root, we all know from indices, when you have square root of a function, then it means it is raised to the power of minus 2. So we say y equals 4x raised to the power minus 3 plus 2x raised to the power 3, all raised to the power 1 over 2. Now, having done this, then we'll say let u equals 4x raised to the power minus 3 plus 2x raised to the power 3. That is, u should be what is in this bracket. Then we can now say y equals u raised to the power 1 over 2. Recollect that if you are to find our dy dx will be dy dx equals dy du multiplied by du dx. So our du dx here, that is du dx, will be equals to minus 3 times 4, that's minus 12x raised to the power minus 4 plus 6x raised to the power 2. And our dy du will be equals to 1 over 2 u raised to the power minus 1 over 2, which is the same as 1 over 2. What's our u? U here minus 1 over 2. So having done that, we just fix in our du dx and our dy du into the formula. So we are going to have dy du, dy dx will be equal to dy du. What's our dy du here? We have 1 over 2, open bracket 4x raised to the power minus 3 plus 2x raised to the power 3 raised to the power minus 1 over 2 multiplied by du dx. And our du dx is minus 12x raised to the power minus 4 plus 6x raised to the power 2. So, as you can see, we have treated this, and these are the y dx. So this is chain rule, or we call it function of the function. So in our next class, by just doing this, you see that we are going to treat the differentiation from the first principle. How do we get, what do we understand by the y dx, or how is it gotten, or what is the definition of the y dx? That will be in our next class. Thank you very much.